Now this problem is related to addition elimination mechanism. Let us read this problem. Question says fluoride ion is a not good leaving group, so F minus ion is not a good leaving group. Because F minus ion is not polarizable. And that's why SN1 and SN2 reaction, if fluoride ion is a leaving group, does not take place. So question says, if we have fluoride ion as a leaving group and if we have subnucleophile, in this case SN1 reaction does not take place, as well as SN2 reaction does not take place. But if this fluoride ion is in the benzene ring, that is 2,4-dinitrophenyl, so 2,4-dinitrofluorobenzene, and if this time we have a nucleophile, that is nucleophilic aromatic substitution reaction, now this reaction takes place. And the question is why this takes place. So to answer this question, we have to look the mechanism of SN1, SN2 and nucleophilic aromatic substitution. So let us discuss first SN2. In case of SN2, nucleophile attacks on this carbon and fluoride ion goes, both happens in the same step. That is, loss of fluoride ion is in the part of rate determining a step. So in this case, basically this reaction will not progress. Loss of F minus is the part of rate determining a step. That is, if F minus is a poor leaving group, then this reaction will be slow. SN2 is a one step process. We can make the potential energy diagram for this process also. So this is one step process, this is SN2, this is reactant, and here we have product. And this transition state involves loss of F minus, that is breaking of carbon fluorine bond. So loss of F minus is a part of rate determining a step. So that is, this will control the rate. So F minus is a bad leaving group, so it will decrease the rate. The same thing we can also understood, rate can be written as alkyl halide times nucleophile for SN2 reaction. If I have good leaving group, rate will be faster. Now let us say case of SN1. In case of SN1 reaction, first step is loss of leaving group, and then we have a carbocation. Now F minus is a bad leaving group. So first step is rate determining a step. So this step will become slow because F minus is a bad leaving group. Same thing we can see in terms of potential energy diagram. So if we make potential energy diagram for SN1 reaction, first step is slow and the second step is fast, because in the second step a nucleophile will attack on this carbon. It is a bond formation process. So second step is fast step in SN1 reaction. So F minus lives here, and that is a part of rate determining a step. So reaction becomes slower. So F minus bad leaving group, reaction becomes slow. So this side we have reaction progress. This side we have potential energy. Same thing for this graph, we have potential energy this side. This side we have reaction progress. Now let us say mechanism of nucleophilic substitution, nucleophilic aromatic substitution. So in case of nucleophilic aromatic substitution, the first step is attack of nucleophile, and this step is slower step because we have lost aromaticity. So this side we have aromatic, this compound is not aromatic. So basically there is a loss of aromaticity. So this step is endothermic as well as slower step. So this step is rate determining a step. Now we have a nucleophile here. Now second step we have in nucleophilic substitution reaction. This lone pair pushes this fluorine to go out. So first step is slower step, but the second step is faster step because it gains aromaticity. So this compound is not aromatic, but this compound is aromatic. If I make a potential energy diagram, the first step is slower step and the second step is faster step, and F minus lives in the second step. So F minus lives here. Since this step is faster step, loss of F minus does not control the rate of reaction. So loss of F minus is involved in the faster step. So it does not control the rate of reaction. So this side we have progress of reaction and this side we have potential energy. So F minus is not a part of rate determining a step. So F minus does not control the rate of reaction. So nucleophilic aromatic substitution reactions happens because F minus, whether it is a poor leaving group or it is a strong leaving group, it does not matter. For nucleophilic substitution, poor or good leaving group does not matter. So what we said, we can summarize. We said in case of SN1 reaction, loss of leaving group is a part of rate determining a step. Similarly, in case of SN2 reaction, loss of leaving group is a part of RDS. But in case of nucleophilic aromatic substitution, that is SNAR, aromatic nucleophilic substitution, so nucleophilic aromatic substitution, loss of leaving group is not a part of, and that's why it does not changes the rate. So either we have a F minus, or we have Cl minus, or we have I minus, or we have Br minus. In all cases we will have SNAR reaction. So SNAR reaction is possible for all leaving group. These all leaving group will give SNAR reaction. But SN1 and SN2 we will does not have for fluoride ion. So no SN1, no SN2, because F minus is a poor leaving group. It is not polarizable, a small ion, so negative charge is strongly held, so there is no tendency to be polarized.